Welcome, everybody, to my presentation about Mission to Mars. See, the reason why I started to do Mission to Mars is because we can imagine a world, possibly, that we can one day live on a different planet, including Mars. What life is like on Mars compared to how life is like on Earth today. We can use astrobiology, we can use all different kinds of biology and evolution to determine what life is really like on Mars. Because, it's been in discussion for a very long time and there's a lot of evidence. But I'm here kind of to talk about Mars itself and basically evolution, its own biology, everything that we can determine living on Mars one day. So, my abstract, imagine a world where humans have established a civilization on Mars, becoming the next generational civilization of the mysteries behind the red planet. This eventually is the evolution I'm talking about in my research paper in this presentation alone. It's not far fetched as may seem. To make a vision where reality, we need to understand the conditions necessary for human civilization to flourish on the surface of Mars. This idea includes determining the planet's history and initial conditions, as well as the challenges and dangers that come on living on the planet. So we have our introduction to Mars. Examine the initial conditions for Mars survival. We can gain insight to what life is like on the planet and how we can terraform it and to make it more hospitable place for humans. This is a process of terraforming is a complex one, involving manipulation of the planet's atmosphere, temperature, and surface conditions. One key factor in this process is understanding the planet's history and how it evolved over time. By examining the planet's geological features, we can gain insight to the processes that have shaped it, how the process might harness to create a livable, hospitable environment for humans on the surface of Mars. Discussion. In what ways is it possible for the future to settle on a new planet? What are the evidence of the Martian surface harnesses we can collect back on Earth to determine what's the future of terraforming our planet, how life forms begin, history of how planets came through in evolution, and just talk about the beginning. 4.5 billion years ago. We're going to start from the very beginning. So, Mars's formation started in the inner solar system 4.5 billion years ago from a cloud of dust and gas that eventually our sun formed and eventually collapsed into a disk with all this rock. The sun pushed all the gases away from the outer solar system, leaving behind rock and dust, creating our terrestrial planets, our rocky planets, including Mars. So including the Earth and Mars, and leaving behind the gas for the gas giants. Now, we reach a period where millions of years after the planet was formed, the heavy bombardment period. See, meteors and asteroids kept crashing into the planet, but that was a result that brought life to Venus, Earth, and Mars from meteors and asteroids carrying liquid water, other primitive life forms. But something had to change. Why? You see geological features on Mars. Mars was also hit by a Pluto-sized object, leaving behind a very low elevated northern hemisphere to a very high elevated. So it's very misshapen, if you think about it, because of the big object that slammed into Mars. Now, here's what really changed everything on Mars. But going to 4.1, 3.5 billion years ago, Mars lost everything. But how did it lose everything? And just that split seconds, hundreds of millions of years after this solar system was born, and after the planet was, gaining everything. Well, chemical changes causing the cooling of Mars's core, and also the sun blasts high charged solar flares towards Mars, altering its magnetic field and stripping the atmosphere away. Mars froze, volcanically active, high trace of iron mixing with oxygen, water, and sunlight, and that's how you create iron oxide or rust. So, magnetic field comparison to the Earth and Mars. See, Earth's magnetic field is 40 times weaker. Sorry, Earth's magnetic field is 40 times stronger than Mars, about 65,000 nanotesla. So Mars's magnetic field is very, very, very weak. And this is my composition pie charts to the composition of Mars. So this is what I made on Google Excel, and I just took that as some evidence I got from the internet from an article, and yeah. So composition of Mars. So Mars is entirely mostly carbon dioxide in its atmosphere. Only 2% argon, 1.9% of nitrogen oxide, 0.14% of O2, and 0.06 of CO. And again, these are very small percentage compared to mostly just carbon dioxide. And this is all because of, 4.5 billion years of evolution that destroyed Mars. So research of photosynthesis on Earth and Mars. How is that compared to how we're going to do photosynthesis on Mars and how photosynthesis works on Earth? Well, how we're going to send the humans due to hazards that we have encountered on the Martian surface. Years of intense research, scientists have confirmed that billions of years ago, Mars may have had the first generation of life forms, even water on its surface. So this is what we created, this is like a biosphere. So a biosphere is basically taking all the conditions we have on Mars, but we're creating kind of just a environment similar to Mars, and by using a capsule like a biosphere. And this is actually a biosphere in Canada, which this is taken from an article that I've cited for this evidence, so these are all connected. So CO2 plus water plus energy, and then glucose to oxygen. And that is the abundance to how photosynthesis works here on Earth. And this is what needs to be created for Mars. But when you have high intense stream particles of hazardous solar winds creating on Mars, creating in a very thin atmosphere, mostly carbon dioxide, well, that photosynthesis is not gonna help on Mars. It's not gonna do anything. It'll just die. So how can we change that? Terraforming Mars. So there are many speculations on how we can start creating a magnetic field. We can use anything that we can clean up the entire atmosphere. We can also bring water back. Well, how do we do all those? Well, starting with its core to remagnetize everything. We can use radiation from the sun by using solar panels, and we can drill through the outer core of Mars to generate an electrical current to start magnetizing and reheating the Martian core. And we can use electrolysis to break down carbon dioxide into its components of carbon monoxide and oxygen ions. We can also drill through the poles of Mars, creating a heat drill to melt some ice and let the water flow into streams, rivers, oceans, lakes. And we can just use these natural resources into drinking water and basically survival, I guess. That we can use it for, agricultural and geological standforms. Pros and cons of how we're going to transport the essentials that we need to actually start doing stuff like this. Well, that's going to be very difficult because it takes a lot of careful estimates of position between Earth and Mars. Because Earth and Mars are completely different orbits around each other, around the sun. So from Earth, Mars can be in a completely different side of the sun. It can be somewhere else. It just needs careful mapping and very careful how you're going to figure out if Earth and Mars are going to be kind of right parallel of each other. But that's a very good question because it takes a lot of time to make an orbit around the sun for Mars. Even it's 140 million miles away from the Earth too. Time also plays a very big role in it. independent variant because it takes so much time being 140 million miles away. It probably takes a few years just to get to Mars to bring all the essentials that you need for technology and how we can understand how to terraform Mars. What kind of cargo is needed? We're going to be heavy, or how much fuel do we need to get across from Earth to Mars through empty space? Human life on Mars is likely a no. See, and the reasons why, because the average temperature of Mars is negative 80 degrees Fahrenheit or negative 60 degrees Celsius. The average temperature of the Martian equator is about 80 degrees Fahrenheit, but its composition on its atmosphere is dangerous. No liquid water, has possible life, but it's constantly blasted by harmful radiation. And similar to Earth, has really similar composition of climates. When you're away, like north or south of the equator, it gets colder when you get towards the poles. If you're on the equator, it's much warmer because it's more direct sunlight. When you have the orange part, it's more tropical and it's more temperate. That's what we see on Earth as well. The further you get from the equator, north or south, the colder it gets. If you're on the equator, it's very warm, very tropical, very warm, temperate, semi-arid. Has all those features too that we see on Earth. And again, this is my article. So this is an article I found on the internet. I've cited them, and then I explain everything. So everything, the loss of water solely through the atmosphere cannot explain both the observable and deuterium of hydrogen signals in the Martian atmosphere. Large amounts of water in the past, instead of study a process that would combination of two mechanisms, the trapping of water and minerals in the planet's crust is a loss of water in the atmosphere. And this is from What Happened to Mars' Water. Is it still trapped there? And it's from Caltech. It's a 2021 article, and this is the link to it in my explanation to the quote. This causes the Martian atmosphere to have high amounts of CO2 and preventing heat from coming through, causing it to bounce off into space. The significant effects suggest that despite the cooling the core below Mars, the planet was not safe from the sun's solar flares to begin with. Mars is still facing such threats today. According to the quote, the loss of water on Mars through evaporation alone does not provide a complete explanation for the presence of deuterium in the Martian atmosphere and past evidence of water on the planet. So it's many guesstimates and estimates of how Mars was like in the beginning. And then I have some really cool Mars facts to show you guys. So Mars was actually named after the Roman god of war and blood. Mars has two very small tiny moons, Phobos and Deimos. The biggest one, Phobos, I think it's about 14 miles in diameter, where Deimos is only about 9 miles in diameter, which is very, very tiny. Olympus Mons dwarfs everything ahead. It's the highest point of our solar system, 72,000 feet above sea level, compared to 29,035 feet here on Earth. Which that's very crazy. It's 3 times that. And then this is my citations, all 12 of them, for my presentation. So I'm going to say thank you guys so much. And my conclusion is it's a very dangerous situation that we're putting humans on Mars. But hopefully one day, as technology evolves, we can determine how fast everything is. We can determine, learning about biology on different planets. We can create the environment for our future generation to eventually build a society and a utopian on Mars. And that's my conclusion. I want to say thank you guys so much. My acknowledgements, thank you, Mr. Dong, in Scientific Writing, for everything. And I'll see you guys next time. Bye, everybody.